Hi guys, welcome back to my channel. So in this tutorial we're going to look at this integral from 0 to pi over 2 of sine of x divided by sine of x plus cosine of x all to the 5th power. So if you haven't subscribed to my channel, make sure you hit the subscribe button for more engaging tutorials. So let's solve this integral. We are going to solve this integral using the King's property. So the King's property states that the integral from a to b of f of x dx can also be written as the integral from a to b of f of a plus b minus x all dx. This is a, this is plus b. So this is the King's property. So we can call our original integral I. And let's use the King's property to transform this our integral. So from the King's property, our integral I can also be written as the integral from a to pi, integral from 0 to pi over 2 of sine of that means wherever you see x, you are going to plug in pi over 2 minus x, because 0 plus b, a plus b here is equals to 0 plus pi over 2, which is pi over 2. So that is pi over 2 minus x all over sine of pi over 2 minus x plus cosine of pi over 2 minus x, all this to the 5th power dx. Sine of pi over 2 using the double angle identity. Sine of pi over 2 minus x is cosine of x, and cosine of pi over 2 minus x is sine of x. That is from the double angle identity. So plugging those in, that can be the integral from 0 to pi over 2 of sine of pi over 2 minus x is cosine of x divided by sine of pi over 2 minus x is cosine of x plus sine of x, all this to the 5th power dx. This is pi over 2, sorry about that. So this one, this is the integral transformed by the King's property, and this is our original integral. So let's add them now and combine them together. I plus I, our original integral, is the integral from 0 to pi over 2 of sine of x all over sine of x plus cosine of x all raised to the power 5 dx, plus the integral transformed by the King's property is this one, which is the integral from 0 to pi over 2 of cosine of x all over cosine of x plus sine of x raised to the power 5 dx. So I plus I is 2I is equals to the integral from 0 to pi over 2. Combine them. Denominators are the same, so we can just add the numerators. That is sine x plus cosine of x all over sine of x plus cosine of x all to the 5th power dx. So 2I reduces to this one will cancel one of them at the bottom, leaving 1. So the denominator reduces to the 4th power now, plus cosine of x all to the 4th power dx. So with this one, what we can do here now is we can factorize cosine of x out, and this one becomes sine of x over cosine of x plus 1 all this to the 4th power dx. So 2I is going to be the integral from 0 to pi over 2 of 1 all over cosine to the 4th power of x. Sine over cosine is tan of x plus 1 all to the 4th power dx. So 2I is going to be the integral from 0 to pi over 2, 1 over cosine to the 4th power is secant to the 4th power of x in the numerator, and this is 1 plus tan x all to the 4th power dx. So 2I is going to be the integral from 0 to pi over 2. This one can be, the numerator can be split into secant square x times secant square x dx all over 1 plus tan x all to the 4th power. And secant square x can also be written as 1 plus tangent square x from the Pythagorean identities. So 2I is going to be the integral from 0 to pi over 2 of 1 plus tan square x times secant square x dx all over 1 plus tan x. We can now use a u sub here. We can let u to be equal to tan of x to the 4th power. Sorry about that. So when x is equal to 0, then u is going to be tan of 0, which is 0. When x is equals to pi over 2, u is going to be tan of pi over 2, which is infinity. So our integral, we have du dx is going to be secant square x dx. In that case, du is going to be secant square x dx. So we can take our integral from the x world into the u world now. So our integral 2I is going to be the integral from 0 to infinity of 1 plus tan square x is u squared times secant square x dx is du all over 1 plus tan x, that is 1 plus u all to the 4th power. So this is what our integral has been reduced to. This one, we can use another u sub again. We can let t to be equal to 1 plus u. When u is equal to 0, t is going to be 1. When u is equal to infinity, t is going to be infinity plus 1, which is infinity. And dt du is going to be 1, so dt is going to be equal to du. So our integral in the t world will now become 2I is going to be the integral from 1 to infinity now of 1 plus u is t minus 1, so we can find u here is going to be t minus 1, so that is 1 plus t minus 1 all squared all over 1 plus u is t to the 4th, and du is equals to dt. So 2I is going to be the integral from 1 to infinity of 1 plus foiling that's going to be t squared minus 2t plus 1 all over t to the 4th dt. 2I is going to be the integral from 1 to infinity of t squared minus 2t plus 2 all over t to the 4th dt. So 2I is going to be the integral from 1 to infinity of, this one can be split into t raised to the power negative 2 minus 2t raised to the power negative 3 plus 2t raised to the power negative 4 all dt. So 2I is going to be integrating this, that is going to be is t to the negative 1 over negative 1 minus 2t to the power negative 2 over negative 2 plus 2t to the power negative 3 over negative 3. Integrating that from 1 to infinity. So 2I is going to be, this is negative 1 over t plus 1 over t squared minus 2 over 3 times 1 over t to the third, integral from 1 to infinity. So we are going to have 2I is equals to limit, as let's say k approaches infinity, of negative 1 all over k plus 1 over k squared minus 2 over 3 times 1 over k to the third, minus, plug in the lower limit, negative 1 over t, that's negative 1 over 1 plus 1 over 1 squared minus 2 over 3 times 1 over 1 to the third. So 2I is going to be, this one approaches 0 as k approaches infinity, the same as this and the same as this. So everything approaches 0 for the upper limit, which is 0 minus, this is negative 1 plus 1 minus 2 over 3. So in the end, our integral reduces to 2I is going to be equal to, this is 0 and this is positive 2 over 3. So in the end, our integral reduces to 1 over 3. Therefore, our integral I, which I can't remember. So if you go to the very top, this was our integral. Integral from 0 to pi over 2. So which is the integral from 0 to pi over 2 of sine of x all over sine of x plus cosine of x all to the power 5 dx. This is evaluating to 1 over 3. That is by utilizing the King's property and some use up. So if you find this helpful, make sure you subscribe to my channel. Smash the subscribe button for more engaging content like this. Thank you so much for watching this video, and I will see you in the next one. Bye bye.